Hello, boys and girls. This is Drive Through. As always, it's sponsored by The Deli. Get yourself a classic grilled cheese with American bacon and on white bread. But anyway, we're going to go do problem number 11, page 782. This is the problem here. Quite long. It's a proof. So what I'm going to first do is show you what my variables are. And they are u equals the vector of a, b, c. W equals the vector of d, e, f. V equals the vector of g, h, l. And z equals the vector of m, n, o. Okay, so I'm going to show you the left side of the equation first so we can compare both sides at the very end. So here goes. First, I found u cross v, and this is the setup of the equation, and this is what I got. So this is u cross v, and then just make sure you remember there's a negative sign in front of the j because I messed that up and it really screwed me over for the rest of the problem for a while. But anyway, that's u cross v. This is w cross z. The same thing, make sure you remember that negative j because it'll screw you over. And then this is going to be renamed as vector q, and I renamed this as vector p. And that'll make sense in just a second, because vector q cross vector p is this setup, and it's really long and tedious. But anyway, this is the equation this is the vector that's non-simplified, and then this is the vector that is simplified. And anyway, we'll stop here and then we'll do the right side of the equation and then we'll compare these two at the end. So 1 second. Okay, I'm back. So this is the right side of the equation. U cross v dot z times w minus u cross v dot w times z. So first of all, we're going to be smart and we're going to take u cross v from what we did before, and this is what it equals. And then here's w and here's z from before. And then so u cross v dot z is going to give us a scalar because we do this first, and anything that's dotified equals a scalar. So this is the scalar, and then you're going to multiply it by vector w, which gives you a vector again, and this is vector u cross v dot z times w. And then we do the same thing for u cross v dot w times z, and this is u cross v, this is u cross v dot w, and then this is u cross v dot z, or times z. And these are both vectors up here, so we're going to subtract them, and we get this big long thing, and then all these values cancel in each separate thing right here. So basically, after I rearranged the symbols and canceled everything out and tried to make it look like the left side of the equation, this is what we get. And then comparing those two, this is what we get, and as you see, they're both the same, so we proved it. Just make sure you include all your negatives, be careful, and then you can just plug and chug. Boom.